Hello students, so welcome to this channel. In this session we are going to discuss about some important trends in the size and the radius of anions, cations and neutral atoms, right? So this is a very important topic, and you can find at least one or two questions in the almost all competitive examinations. So let us try to solve some questions, and we need to understand some relationships between these ions and atoms, right? I am going to share that there is a shortcut to find out. So size of any species, let it be ion or a neutral atom, that is a first of all it is inversely proportional to the nuclear charge, right? Nuclear charge, and this this relationship is applicable only for the isoelectronic species, right? If you have if you come across isoelectronic species, then you can apply this one. This nuclear charge is nothing but the number of protons, right? Number of protons, or you can also construe that as atomic number. Okay, you can also construe that as atomic number. Now if same if the species of a same element is given, for example F plus, F minus and fluorine, if such cation and anion of the same element and its neutral atom is given, then the size will be directly proportional to magnitude of negative charge and inversely proportional to the magnitude of positive charge, right? So this is the relationship which is applicable to elements of the or species of the same element, right? Now let us solve this one. Fluorine minus, oxygen and oxygen minus. Now I am going to divide it into two species. Fluorine and oxygen, they are neutral, and F minus and O2 minus. We know that if the magnitude of negative charge increases, then size will increase, right? So surely the anions will be greater in size. So I can write like anions will be greater in size than the neutral atom. So 100% anion should come first. Now among anions, fluorine and O2 minus, F minus and O2 minus will be bigger in size because we need to apply here. These two are isoelectronic species, right? Now you need to apply the first relationship. So greater the nuclear charge, lesser the size. So which means the fluorine will be smaller in size and oxygen O2 minus will be larger in size. So this the order is O2 minus is larger in size than fluorine, F minus. Then comes fluorine and oxygen, and of course here again we can apply the first one, nuclear charge. Which one? Nuclear charge of fluorine is 9, which is nothing but the atomic number, and oxygen, for oxygen it is 8. So greater the nuclear charge, lesser the size, right? So which means fluorine is smaller in size than oxygen. Oxygen is bigger in size. So this is the order. Now this next one, as we discussed earlier, we know that size is directly proportional to the magnitude of negative charge and inversely proportional to the magnitude of positive charge. Or in other words, I can also say that the cations are always smaller in size and anions are larger in size than the parent atom. So the order will be I plus will be smaller in size than iodine, than I minus. So this is the order, right? The third one is we have calcium 2 plus, potassium ion and argon, which is a neutral one, inert gas, Cl minus and S2 minus. Now when we analyze the number of electrons, we can understand that all these species have 18 electrons, which means I can call them as isoelectronic species. For isoelectronic species, I can apply the first relationship, that is size is inversely proportional to the nuclear charge or atomic number, whatever it may be, right? Atomic number, all around the same. So atomic number of this one is 20, right? And this is 19, and for this is 18, this is 17, and this is 16. So if atomic number increases, size will decrease, which means calcium 2 plus will be smaller in size, then potassium ion, then argon, then Cl minus, then S2 minus. So S2 minus is the sulfide ion is the bigger in one with bigger size. And the last one is sodium ion, magnesium 2 plus ion, chloride 7 plus ion, and silicon 4 plus ion. Again they are isoelectronic species. All these species have 10 electrons if you analyze that. Now we know that again size is inversely proportional to the atomic number, right? Greater the atomic number, lesser the size. So for chlorine atomic number is 17, for silicon atomic number is 14, for this one 12, and for this one is 11, which means chlorine 7 plus is smaller in size, silicon 4 plus is next one, then comes magnesium 2 plus, and finally Na plus, right? And remember students, this relationship is applicable only for the isoelectronic species, right? So thank you. Happy learning.